Here's how our solar system looked in 1600 BC, in 1524, 1606, 1742, 1846, 1934, and today.
The only problem is, none of these models are accurate.
We've been looking up at the stars and wondering about our place among them for about as long as we've been around.
Look at the stars.
But even today, with our monumental advancements in space technology and optics, it's almost impossible for us to grasp just how vast, how cosmically enormous our universe really is.
So, just how big is our universe? And is there a way for our tiny ape brains to truly understand the vastness of space? I wanted to find out.
So I read some books, talked to some smart people, and hit the road. Because once you appreciate how small you are on a cosmic scale, that misspelt name, that unreturned phone call, that show cancellation, it all fades into triviality as you realize that none of it really matters in the grand scheme of things.
Darling, you send me, I know you send me, darling,
If you look up a picture of the Earth and our moon, you typically get a picture like this, where the moon and the Earth are shown quite close together. But in reality, our moon orbits the Earth at a distance of 384,000 kilometers. Something more like this. In fact, you could fit every single planet in our solar system in the distance between the Earth and our moon. If we zoom out even further and take a look at our solar system, this distortion becomes even greater. It becomes literally impossible to find an image that even comes close to representing our solar system to scale. And the reason for this is simple. If you were to map out our solar system on an A3 piece of paper, the planets would become microscopic. It would be impossible to even see them. And this is the fundamental problem with trying to accurately represent the scale of our solar system. It's simply too big. So let's try and get a little bit of perspective.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on.
The date was January 19th, 2006, and in Cape Canaveral, Florida, a NASA probe the size of a grand piano left Earth atop a rocket traveling 57,000 kilometers per hour on a 5 billion kilometer journey that would take it the better part of 9 years to complete. Its target? The loneliest little dwarf planet in our solar system, Pluto. Of course, I'm talking about NASA's New Horizons probe and its mission to complete our planetary photo album. On July 14th, 2015, it completed its mission, getting within 12,000 kilometers of the planet's surface and providing the rest of us with some stunning images. This was a huge feat and one of the greatest scientific achievements of the 21st century. But again, to truly understand how incredible this was, you have to understand the true scale of our solar system. So let's say that Earth is representative of this ball. On this scale, Pluto would be, well, roughly the size of this ping pong ball. So how far apart are these two celestial objects? 10 meters? 50 meters? 100 meters? Not even close. These two balls would be 80 kilometers apart. From where I live here in Vancouver, that's halfway to Seattle. Despite this enormous distance, NASA's scientists were able to calculate and guide this probe, which on our scale would be smaller than a grain of sand, all the way to within a cosmic hair of Pluto. Can you imagine sending one of these grains of sand 90 kilometers in that direction, and then 9 years later, have it come within a hair of that ping pong ball? It's just insane. But what if we didn't represent our planet with a basketball, but with something a bit more manageable? Like a pea. Let's call this our p-scale. What the p-scale does is really put into perspective not just the vast distances between the planets in our solar system, but also the huge disparity in the sizes between the planets, none of which is more apparent than the magnitude of our nearest star, the Sun.
there's no sun up in the sky.
This is Dr. Simon Foster.
Hello, my name is Dr. Simon Foster.
Simon's primary area of research is in
Solar terrestrial physics.
So, what better person to talk to about our solar system? I went to visit Simon at the Imperial College in London. But before we could get around to talking about Simon's favourite topic,
Something called sunspots, and I'm obsessed with them.
I wanted to know, how does he explain these vast cosmic distances to the layman?
And the nearest explanation I can give is that, especially now I've moved out of London, it's like being on a long train journey. So you start in a central location, I don't know, King's Cross, Victoria, something like that, and you're going to another city. As you're leaving, at the beginning, you're going to hit train stops fairly regularly. And then the further you get from the centre, it gets longer and longer and longer between stops, until you're right out at the city limits. And then you could go an hour or two before you hit another stop. And that is about the best analogy I can give for what it's like in our planet going to another solar system.
So anyway, about the sun.
The sun is... So if you think about the sun's like 99.99999% of the mass of the solar system. And to give you an idea, it's losing millions of tons a second through fusion. So its actual mass is turning into energy through E equals mc squared. It's just losing a colossal amount of mass every second. Now, you look at the numbers, and even as a scientist, you look at these and you think, my God, these numbers are huge, on Earth. You're talking about billions of tons. But in terms of the sun's huge. It's like I don't know, shedding a hair. It's like sneezing. It's or like a skin cell. It's nothing.
Our sun dwarfs our planet in every sense of the word, having a diameter 109 times larger than Earth's.
On our P scale, the sun is the size of an exercise ball.
So here's how the rest of our solar system lines up on our P scale. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and of course, Pluto.
On this sort of scale, we might have some luck fitting our solar system onto something the size of, say...
a Vancouver suburb?
So, here we are at the sun, in the centre of our solar system. And about 30 metres or so in that direction is the first of our inner rocky planets, Mercury.
57,910,000 kilometres away from the sun and 284 times smaller than it.
Another 20 metres past this is Venus, which is 3 times larger than Mercury, but still 114 times smaller than our sun. And then there's us. Home sweet home.
Everyone you've ever known and loved. Everyone you've ever heard of. Every human being there ever was lived out there on this lonely little rock, drifting through space 149,600,000 kilometres from its closest star. Moving out another 40 metres and we reach the last of the rocky planets. On the edge of our inner solar system, Mars.
And this is what the fuss is all about. In 1969, NASA sent 3 astronauts from here to around about here. And now in 2035, NASA is wanting to send an entire team of colonists from here.
We just place the spacecraft on a trajectory to Mars and let it coast for 7 months and 300 million miles until it reaches the planet.
To here. Maybe now it's easier to get a bit of perspective as to why this is such an astronomically huge scientific endeavour.
Further than any human being has ever travelled from our planet, by a factor of 77,955,000 kilometres.
After Mars, we leave the inner solar system for Jupiter.
The distance between Mars and Jupiter is almost twice as far as the distance between Mars and the Sun.
which is why we distinguish between the inner and the outer solar system. We're now 778 million kilometers away from the sun and 391 meters away from our exercise ball.
After Jupiter, we have the rest of the outer solar system. Saturn, Uranus.
Being more than 2 kilometers away from where we started, I can't even fit Neptune in this suburb. To do that, I'd have to cross the harbour. So, here we are. We made it to the edge of our solar system. Pluto. Can you see it? It's absolutely minuscule compared to our sun. And in terms of distances, well, I remember first building one of these model solar systems in primary school, and it's still done today around the world to teach relative cosmic distances to kids. But what does the adult version of this look like?
To answer that question, I had to fly to Sweden.
Welcome to Stockholm and Arlanda, where the local time is 9:57 a.m. Scheduled arrival time.
This is the reason I came to this frozen tundra. This is the Ericsson Globe. The stadium started construction in 1986, took 2 years to complete, and broke its record attendance of 16,531 in 1998, when the Spice Girls came to Stockholm. It also happens to be the largest hemispherical building on Earth, with a diameter of 110 meters, and also plays the role of the Sun in the largest scale model solar system on the planet. The project was the brainchild of Niels Brenning and Gösta Gram, and has been slowly growing year by year since 1998. I went to visit Professor Niels in his office at the KTH Royal Institute of Technology, a university in Stockholm's north.
I am Niels Brenning. I am professor in plasma physics.
Okay, before we get into this, a little bit of background on the Swedish solar system. The solar system, much like our P-scale solar system, takes the diameters of the Ericsson Globe and compares it to our sun. It then crunches the numbers and scales the planets and their distances accordingly. The planets of the inner solar system can all be found within Stockholm. For the outer planets though, well, you have to travel outside of the capital. Here we find Jupiter, Saturn, Neptune, Uranus. To find Pluto, you have to travel a staggering 300 kilometers from the Ericsson Dome to the quaint little town of Delsbo. And compared to the Ericsson Dome, Pluto is about the size of a shot put ball.
Okay, back to Niels.
It came up as a pedagogical project. I was talking to my own kids at school and was thinking about models of solar system to explain the distances. And then it struck me that the difficult thing is to make the sun. It's so much bigger than the planets and everything, so it's difficult to afford. And then it struck me that we could use the already built globe. At the same time, when we developed this, me and Gösta Gram, we have done this together, we realized that all the planets are associated with culture, history, mythology. So one can, at the same time, we tried to find connections between the planets, the location they are, and some mythological event to broaden this into not just science, but also human science. The thing was to find where the planets would be. And actually what I did, and this is not something I told many, but I took out a map of Stockholm, and I realized that I would have to move around in various directions to see where they would fit. So I took a rubber band and I marked the planets on it. So I could stretch and contract the rubber band and move it around. And then I found that, okay, this is a good fit. Here I can get the subway stations exactly at the first inner planets. And they would be each their own subway station. Then I checked and it was a good scale.
It's true. Conveniently and quite coincidentally, the distances from the Ericsson Dome and the inner planets line up almost perfectly with the city's metro stations. And so with that, I wish Nils and a Joe...
That is definitely not pronounced correctly.
got an O card and hit the rails on a voyage through our inner solar system. The Ericsson Dome is located in the southern district of Johanneshovn and was, obviously, the first stop on our interplanetary day trip.
Alright, hello and welcome to the centre of our solar system. As you can see behind me, that is the Ericsson globe, and it's going to be representing our sun on this cosmic voyage. And although this building may be millions and millions times smaller than the actual sun, don't let that take away from how amazing this building actually is. This is the largest spherical building in the entire world.
From there, it's a short trip from Globen Station to Slussen, where the Stockholm City Museum was closed. Admittedly, not a great start to our interplanetary voyage. Luckily for me, Nils gave me a great description of the model before I left.
And the particular thing about Mercury is that it's very hot. And there is a place on Mercury where you actually can melt lead when it's facing the sun. And the artist then, Peter Varhelyi, he designed a globe of copper with signs on them that would symbolize historically and mythologically Mercury, and he also had it heated. So it's standing there at the City Museum, and in the winter time the snow melts on it, and often you can see kids taking off their gloves and standing with their hands on Mercury. So that's the first one.
Oh, I'm sure it would have been awesome, Nils. Anyway, we're 2.9 kilometers away from the globe. Moving on.
Then we have Venus, and that is actually one of the reasons I got enthusiastic about this project. It is here at this school, Royal Institute of Technology.
I visited the second warmest planet in our solar system in the middle of March, meaning it was freezing cold and it was covered in snow. But a quick wipe down confirmed that we had made contact.
Alright, we are now at the House of Science in Stockholm, and right behind me, just over there, is Venus. We're now 5.5 kilometers away from the Ericsson globe, and yeah, still cold.
Back on the T-Bana, another 12 minutes, and we're at the Natural History Museum.
Alright, so we've now arrived at the Natural History and Space Museum here in Stockholm. Planet Earth is inside there, along with the Moon. We're now 7.6 kilometers away from the Ericsson Dome. Next stop, Mars.
Mars, the red planet, symbolizing war and other things in mythology, that is the end of the habitable planets, or the small planets, the inner planets, and that's also the end of the subway line you took here. That's in Mörby Central.
Okay, the sun is coming down and we have just reached the outer limits of the inner solar system, with the fourth of the rocky planets, Mars, being held in that building right behind me. We're now 11.6 kilometers away from the Ericsson globe. And no, I have no idea why it's housed in a shopping centre.
From here, the outer solar system spans the entire length of Sweden. It's an incredible piece of science communication, and for me, anyway, the most visceral way I've ever understood the true scale of our solar system. And as overwhelmingly big as this may seem, it's nothing compared to the rest of the universe.
This is meant to give you an impression of the scale of the universe. And what gives me the strongest impression of the scale is that you say, okay, we go on, we have the moon, we have the planets, distant planets, comets, and we are staying within Sweden. So that gives a feeling. Okay, what if we would include the nearest star? And that would be out in space. So you have this tremendous shrinking of the scale, and the nearest star would be out in space. That sort of puts you on the map. We are very small in a very big universe.
Our closest star other than our sun, Alpha Centauri, is 4.37 light years away. On our Swedish solar system scale, there's literally nowhere on Earth that is far enough away from the globe to accurately place this, since it would be more than 300,000 kilometers away, with nothing between them.
It's incomprehensible on a much grander scale than anything else, yes. It's really big.
Our solar system is massive, and our universe even more so. And yet, on this tiny rock, floating in the vast emptiness of space, are people. People who have looked up at the sky and tried to understand our place in that vast emptiness. And when you think about that, about how vast the universe is and how unique it is that life has developed on this planet, it makes you appreciate how special our planet really is and how important it is to keep it whole, clean, and safe.